Okay, so this section is about sets in Python. So we've looked at two types of collections. We've looked at lists and we've also looked at tuples in our previous two sections, and now we're going to go on to another section, a different type of collection, which is a set. So I'm just going to copy some text and paste it into here, which is our broad description of what a set is. Sets are used to store multiple values in a single variable. A set is a collection of unordered, unchangeable, with a little asterisk over here, and unindexed. So it's a collection which is unordered, unchangeable, and unindexed. Set items are unchangeable, but you can remove the items and add new items. We'll see that again because it's relatively important. Unordered. What does unordered mean? Unordered means that that the items in a set do not have a defined order. So that's relatively straightforward. Sets can appear in a different order every time you use them and cannot be referred to by an index or a key. And we're going to try that out later on and see that it fails. We'll use our standard try except pattern for that. Unchangeable. Sets are unchangeable, meaning that we cannot change the items after a set has been created. But again, over here, just this little caveats, I put a but there, but you can remove items and add new items. So whilst we can't change the items in a set, and again, we'll show this with a try except block, you can actually add items to the set and you can remove items from the set. And finally, duplicates. Sets cannot have two items with the same value, and this is a very useful feature of sets because it forces uniqueness onto our data set effectively. So that's quite nice to have if we understand it and use it in the right way. So the first thing we're going to do is, after the talk of it, is let's create a set. So that's our first task, and to create a set is an easy. I'm going to be very simplistic with my variable usage. I'm just going to use S to stand for set, and it's equal to, and a set is created in a curly brace like this, and we can say, for example, we're going to make a set of fruits. So we say apple, and then we can say orange, and then finally we can say banana. So that's a set, and it's got three items inside of it, these three fruits. And we can print our set in the usual way with a print S. We can run that. We get our set. It comes inside of these curly braces. So now we've used parentheses, which is curved brackets, square brackets, and also curly braces. So the square brackets was for lists. The curved parentheses or curved brackets is for tuples, and the curly braces is now for sets. We've got three different things that we can enclose in so far, and we're actually going to see that in a later section when we come to dictionaries that we'll be using these curly brackets again. Anyway, we move on from there. We can also print the type of our variable S, which we're expecting to be a set. We're hoping that we're expecting that the Python interpreter will return us back a set, and indeed we get a class of sets, so that's quite useful. Next on the agenda is we'll separate this out, print, just so that we've got a nice little line. We finished that. That's our standard stuff on sets in terms of that. Okay, let's just say sets do not, and this is from above basically. Where is it? Cannot be referenced by the index or key here. So sets do not allow us to reference an item by or reference an item like a list or tuple, which we've seen before. So with a list or tuple, we could do something like S0, and that would give us the first element of the list. In our case, it would be Apple. So if we do that for a tuple, or if we did that for a list, we'd get the first element. So we try and do exactly the same for a set and run it, and we get thrown this error message, which is type error, set object is not subscriptable. So we cannot do the same for a set as we do for a list or a tuple. And that's one of the properties of the set. So let's just try, we'll do a try except block because we want to continue with the code. Try except, we want to continue with the code without failing it miserably. And let's just assume, we'll take this here, that we wanted to print our set. We know that that's going to fail now. We'll put an exception because we like to show what the actual error message is. So exception as E. We're just aliasing the exception to E. And let's do something like print tried to reference item. But we got this error message over there. So that will be kind of like a graceful move through the code. Instead of throwing us this type error and breaking the code here, it will let us pass, just showing that we couldn't do it. And again, it says set item is not subscriptable. So we were not able to get this item or any of the other index values out of a set. Also, we cannot change the values, right? So it works exactly in the same way, which is if we said that S0 and we didn't want it to be an apple, but we wanted it to be something else like a carrot. So we wanted to set 0 to be a carrot. We try to run it, we get this error message, and we get a similar type of error. We get a type error, set object does not support item assignment. So we've got a not subscriptable, and we've also got a not support item assignment. So let us put that into a try except block in the same way. So try except, that's a nice little pattern here, and we will try to do, we're going to try our assignment over here. So we'll just cut that out and paste it here. We're going to try to do that, and we are going to do something like try to change a value instead, is what we're going to write. Try to change a value, right? So we tried to change a value, but unfortunately we were going to fail, and we're going to pass through this gracefully this time. So we do get, oops, what's the error message? Forgot to put the exception as E, except exception, because we just want to actually print out our error message. So we want to the exception itself. And we run that, and we get there, try to change a value, set object does not support assignment. So neither of things are available for us. Set object does not support assignment, and also the object is not subscriptable. They're just properties of set that we have to understand, and there's reasons for that. And one part of it is that we want the uniqueness, and the other part of it is we on purpose don't want to be able to change them. If we did, we would use a different collection type as one of our, and this is one of our 4 main collection types. So let's just move on. We'll take this print statement just so that it's nicely segregated. So we've thrown some of our error messages, and we've shown some of our properties of sets via the error, like what we're allowed to do, and they're sort of like enclosed in their own little erroneous zone. So the next part of it is the add method. So how do we add items to a set, or what can we do with a set? And I'm just going to run through a couple of them, but we've got this. We want to add an item, or we could actually call it the add method even. So the add method, and just like with lists and also with tuples, if I do type out S here and then put a dot, we've got a whole bunch of methods that are available to us, and it looks like we can do a broad quick count. If I start at the top, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 17 different methods are available to us for sets. The one that we're first interested in is add, so we will just take that one because we want to add one item. And just recall that we tried to sort of like do something and add or change a value to caret, but we couldn't do that. But what we can do is take that same caret and paste it into here like this. And if we just hover over the add, it says here add an element to a set, and more importantly, I was actually looking for whether it returns something or not, but it returns a none. So there's no point assigning a variable to that. It's not like it's going to say, put in caret. It's just going to literally append our set. This has no effect if the element is already present. Now, the reason it says that is because sets cannot have two items with the same value. That's a very nice, useful feature of sets. It doesn't allow duplicates, and we use this in Python in a whole number of different ways where it extracts uniqueness. So we've tried to add an item to the set. Hopefully it will work, and then we can do print something like item added, and then we will print out our set. Maybe even we could do a \n to print it on the next line just below. So we run that and we get item added, and we see that we've got the apple, banana and orange. That's what we had before up here, and now we've got a caret added to the set. So that's the beginning of sets. So now we can add an item to a set, but we should be able to remove an item as well. So we go to remove an item, and there was different methods for this. And if I just go over it just so that you can see, so that I'm not making it up, s dot, we've got a clear as well, which will remove all items, but maybe we'll just leave that out for now because that's removing all items. But we've got a discard in here, we've got a pop, and we've got a remove. So we've got three different ways of doing this. So we've got discard, we've got a pop, and we've got a remove. Right, so we've got three different ways of doing this. Let's try pop first. We'll try the middle one just because it's the smallest in terms of number of letters and for no other reason. So we do s.pop, and the first thing that we note when we do s.pop is in fact s.pop. I wonder if it will pop up that way. No, it doesn't, but it just says it returns us a string. But actually, it's useful enough. An item is going to be removed from the list, but we don't know what at this point in time, and we get back this string. So it's telling us, it gives us a return value. So let's just put popped and then equals s.pop. And we don't know what we're removing at this point in time. All we know is that our list has got our set has got 4 items in it. It's got apple, banana, orange and caret. So which item gets removed? It's a question, or does the function work this way? Did we need to put something inside of it? We're not told that we needed to put something inside of it. So let's just print something like item, just do item popped, something like that, and then popped. That what was removed, and then also maybe we will print the resulting set from the pop. And let's get that there. Do a colon, we've done that, and a \n just to put it on the new line, and let's print out s. So something like this should print out our popped item, whichever one of these 4 is going. Now you might imagine that it's the last one, possibly the first one, maybe it's a random one in the middle. Let's just have a look and see what what actually gets removed, and also print the resulting set afterwards. So we'll see both. We'll see the item that was taken out, and we'll also see the result of it. So we run this little piece of code, and we see that pop has removed the first item from the list. I'm just wondering if we could try negative indexing, if it throw an error. Yeah, it does, because it takes no argument. So when we do pop, we are removing, and we've just literally seen this from the interpreter, we are removing whatever was the first item in this set is the item that gets removed. So it says here item popped apple, and this is the resulting set after pop. So we'll try another one of these. So we've done popped. Let's try remove. So s.remove, and we see here already removes an element from the set. I'll just continue that there because it will pop up anyway. Here, remove an element from a set. It must be a member. So that means it must exist inside of the set. It must be a member of the set. And if the element is not a member, it will raise a key error. So we already know what these key errors are. We might not put this pattern in just to save time, but if it didn't exist in the set, we would get some kind of error message that comes back. So let's try to remove, let's see what we've got in our set. Banana. Okay, we can remove banana. That exists in our set over here. Paste that one in there. And are we getting a return value back? No, this returns us a none. So it's just s.remove. So we're just going to remove, and we'll get something like the resulting set using our, this time the resulting set using the remove method. Remove. Remove method should give us back the same list, but we have removed banana from it. So yeah, let's just run that. And indeed we get that. So we could pop, that removed the first item. We could also do remove, and we could pick which item we wanted to remove from the set. And just the last one, which was discard. So we can do s.discard, which is down here on the list, open brackets, and here it says remove an element from a set if it is a member. Well, that looks exactly like remove, doesn't it? And it also returns none as well, so it still looks like remove. However, unlike set.remove, so this is what the difference is, the discard method does not raise an exception when an element is missing from the set. So sometimes you want to use remove because you want it to throw this exception, say, hey, it doesn't exist in the list, and you can catch this error and so, like, you know, say that to the user, it never existed in the first place. But sometimes you just want it to silently pass through without like some sort of try except block or catching an error. And this is the way. So let's just try and remove something that definitely doesn't exist in the list. So we'll pick another fruit, figs. That does not exist in the list. There's only two things that exist in this list, orange and carrot. So we're just going to try and remove it. And we're expecting that nothing happens, but also we're not going to get an error message back. And if we did try to put figs up here, it would throw an error message back. So maybe we'll try that as well. But this is with the discard. So that is with the discard method, and that runs, and the discard is quite satisfactory there. It's just left us with the original stuff because it didn't exist. And I'm just going to take this figs just for the purpose of showing it and pasting in here. We're not going to do a try except block, although we would need to if we wanted to pass through the code. But when we run this, we get this error message over there, and we get the key error because remove doesn't work on something that is not a member of the set, so something that doesn't exist in the set. So let's just do a Control Z on that. I think we can do, yeah. And so we've got a nice silent removing item, which is discard, and then we could say like a noisy one, which is the remove function, which requires the item to be in the set. So one requires item in the set, one doesn't require the item to be in the set. And that's basically a brief introduction to sets in Python. And I think we'll look at more methods in another section, but this is a good introduction to sets in Python.